So today let us see the questions related to definite integral. There were 9 to 10 questions asked on this topic, combining both Forest Service examination and Civil Service examination. So let's see them one by one. So the question 1 states that if this is satisfied, if this relation is satisfied, then we are supposed to find the value of f of 1. So the function f satisfies this relation, that is integration from 0 to x ft dt is equals to x plus integration from x to 1 t ft dt, and we are supposed to find the value of f of 1. So if you see that we don't know exactly what our function f is, so first thing should be to get value of f1 is to find the function f, and there is no information regarding like what is the function. So the one thing that we can do is to get, like, if we could somehow get rid of this integral sign, then we can reach to fx. So for that, let's use the Leibniz rule. So that states that Leibniz rule that states that if f is a function in, let's say, x and z variable, then partial derivative of del by del z integration az bz f x comma z dx is equals to az bz integration del f by del z into dx plus f bz minus comma z into del b by del z minus f az comma z into del a by del z. So this is the Leibniz rule, and we'll be using it in the given relation about the function f. So let's differentiate the given function with respect to x. So if we do so, differentiating 1 with respect to x. So if we do so, we'll get del by del x 0 to x ft dt is equals to del by del x plus integration x to 1 t ft dt. So if you see that in our case our function f is in one variable, that is t. So if we use Leibniz rule here, so we'll get it as integration 0 to x del by del x into ft dt plus f of x into del by del x of x minus f of 0 into del by del x of 0. This is the left hand side that we got, and it will be equals to partial derivative of x will be 1 plus integration x to 1 del by del x t ft dt plus 1 into f1 into del by del x of 1 minus x into fx into del by del x of x. So if we see that our function is only in one variable t, so its partial derivative with respect to x will be 0. So this term will basically reduce to 0, plus this is fx into partial derivative of x, that would be 1, minus f0 into partial derivative of 0 will be 0, and it is equals to 1 plus, again since tft is a function in only t variable, so its partial derivative with respect to x will be 0. So it will be 0 plus 1 into f1, partial derivative of 1 with respect to x is 0, minus x into fx, and partial derivative of x with respect to x is again 1. So we got our fx is equals to 1 minus x fx. So I can simplify it as fx plus x fx equals to 1. So from here I'll get my fx is equals to 1 by 1 plus x. So we have find out the function fx and we are supposed to find its value at point 1. So f of 1 will be basically equals to 1 divided by 1 plus 1, that is 1 by 2. So f of 1 is equals to 1 by 2, and that's all we are supposed to find in this question. So let's move on to the next question. So the next question says that they have given us a definite integral and we are supposed to show that its integration is equals to this term, that is, so let us name the integration that we are supposed to find as I. So our I is equals to integration from 0 to pi by 2 sine square x divided by sin x plus cos x dx. So we know that for definite integral there is a property that if there is an integration from a to b fx dx, then that integration is same as a to b f of a plus b minus x dx. So we'll be using this property here in I. Let's name it as 1. So I'll get my I as equals to 0 to pi by 2 sine square pi by 2 plus 0 minus x dx divided by sine pi by 2 plus 0 minus x plus cos pi by 2 plus 0 minus x, and this thing will be equals to 0 to pi by 2. Sine pi by 2 minus x is cos x, so it will be cos square x divided by sine pi by 2 minus x is again cos x, and cos pi by 2 minus x is sin x. So we got this, our I is this. So now if I just add in equation 1 and equation 2, add 1 and 2, so I'll get 2 of I is equals to 0 to pi by 2 sine square x divided by sin x plus cos x dx plus 0 to pi by 2 cos square x divided by cos x plus sin x dx. Now if you see that the limit in both the integrations are same, so I can just club in these two together. So I'll get integration 0 to pi by 2 sin square x plus cos square x divided by sin x plus cos x dx, and we know that sin square x plus cos square x is 1. So this term will reduce to 0 to pi by 2 dx divided by sin x plus cos x. Now here what I can do is I can just multiply and divide by root 2 in denominator, multiply and divide by under root 2 in denominator. So if I do so, I'll get my 2i equals to 0 to pi by 2 dx under root 2 into sin x by under root 2 plus 1 by under root 2 into cos x. So it will reduce to 1 by under root 2 0 to pi by 2 dx by sin x into cos pi by 4 is root 2 and also sin pi by 4 is also root 2. So it will reduce to sin pi by 4 into cos x. And we know that there is a formula of sin a plus b, that is equals to sin a cos b plus cos a sin b. So using that formula, our integration will reduce to 1 by root 2 integration 0 to pi by 2 dx by sin x plus pi by 4. Now if I simplify it, I'll get 1 upon sin is basically cosec x, so it will be 0 to pi by 2 cosec x plus pi by 4 dx. So and integration of cosec x is basically is 1 by root 2 ln mod of cosec x, that is x plus pi by 4 minus cot x plus pi by 4, and limit is varying from 0 to pi by 2. Now let's just plug in the limits and see what we get. So it will be equals to 1 by root 2 ln mod cosec pi by 2 plus pi by 4, that will be 3 pi by 4 minus cot 3 pi by 4 and minus ln cosec pi by 4 minus cot pi by 4. Now let's just simplify it further to see what we get. So this thing will be equals to 1 by root 2 into ln, I can write cosec 3 pi by 4 as 1 by sine 3 pi by 4 and likewise cot 3 pi by 4 as cos 3 pi by 4 divided by sine 3 pi by 4 minus ln 1 by sine pi by 4 and minus cos pi by 4 by sine pi by 4. And now let's just plug in these trigonometric values. That will give us ln 1 by sine 3 pi by 4 is basically 1 by root 2, so it will be under root 2 minus cos 3 pi by 4 is minus 1 by root 2 and sine of 3 pi by 4 is again 1 by root 2 minus ln sine pi by 4 is 1 by root 2 and it will be basically reduced to 1 by basically root 2 and cos pi by 4 is 1 by root 2, likewise sine pi by 4 is also 1 by root 2. Now if we just simplify it, we'll get 1 by root 2 into ln under root 2 plus 1 minus ln under root 2 minus 1 and this thing is equals to 1 by root 2 ln under root 2 plus 1 divided by under root 2 minus 1. Now let's see what we are supposed to prove finally. So we are supposed to show it as it is equals to under root 2 log e 1 plus root 2. So we need to get rid of this thing in denominator. So let's just rationalize it inside the log term. So it will be 1 by root 2 ln under root 2 plus 1 divided by under root 2 minus 1 into under root 2 plus 1. So we just multiplied and divide by under root 2 plus 1. So this will be basically equals to 1 by root 2 ln under root 2 plus 1 square divided by, it will be, we can use here a minus b into a plus b equals to a square minus b square. So it will be 2 minus 1, that is 1. Now from here I got, so if you observe that on the left hand side we have 2i. So I got my 2i as equals to 1 by root 2 and we know that there is a rule log of x raised b is same as b log x. So using that it will reduce to 2 times log under root 2 plus 1 ln under root 2 plus 1, that is log natural base as e. So from here I got my I as 1 by root 2 log e root 2 plus 1 and that's what we are supposed to prove. Like this is, we're supposed to prove that the definite integral is equals to this term. So let's move on to the next question. So the next question says that they have given us an integration and we're supposed to basically find its value. So let's name the integration as I again. So it is equals to integration from 0 to 1 tan inverse 1 minus 1 by x dx. So if I just simplify it a bit, it will be equals to 0 to 1 tan inverse x minus 1 by x dx. Now let's again just use the rule that says that integration from a to b fx dx is equals to integration from a to b f of b plus a minus x dx. So if we use this rule here in equation 1, so we'll get our I as integration 0 to 1 tan inverse 1 plus minus 1 plus 1 plus 0 minus x divided by 1 plus 0 minus x dx. So that simplifies to 0 to 1 tan inverse minus 1 plus 1 minus x divided by 1 minus x dx, that is equals to 0 to 1 tan inverse minus x divided by 1 minus x dx. Now let's just add in the equation 1 and equation 2. Adding 1 and 2, so that basically gives us 2i equals to 0 to 1 tan inverse x minus 1 by x plus tan inverse x by x minus 1 dx. Now we know that tan inverse a plus tan inverse b is tan inverse a plus b divided by 1 minus ab. That is tan inverse a plus tan inverse b is same as tan inverse a plus b divided by 1 minus ab. So we'll be using this relation. So this basically gives us 2i equals to integration 0 to 1 tan inverse x minus 1 by x plus x divided by x minus 1 divided by 1 minus x minus 1 by x into x by x minus 1 dx. So if we just simplify it, we'll get 2i is equals to 0 to 1 tan inverse x minus 1 square plus x square divided by x into x minus 1, and in numerator we have 1 minus this x balances this and x minus 1 balances this, that is 1 minus 1 into dx. So if you see that in denominator we got a 0, that is, and also like in this question you're supposed to basically check its sign because it will be infinity or minus infinity based on sign of this term. That is based on sign of this term, it will be basically infinity or minus infinity. So let's just check in sign whether it will be positive or negative. So x minus 1 square plus x square will be greater than or equals to 0 for all x in closed interval 0 to 1. But let's check sign of now x into x minus 1. So x is also greater than 0. So if x is lying in between 1 and 0, so x minus 1 will lie in between minus 1 to 0. So sign of this term is less than equals to 0. So combined sign of this term will be less than 0. So my 2i will be basically equals to 0 to 1 tan inverse negative of infinity, not infinity. Don't do that mistake in exam hall. Always check the sign. So it will be, and tan inverse of minus infinity is basically minus of pi by 2. So it will be integration 0 to 1 minus pi by 2 dx. So from here we'll get our I as minus pi by 4. And that's what we're supposed to find in this question, basically the value of given the definite integral. So let's move on to the next question. So the next question says that evaluate the following integral. So they have given us an integral and we're supposed to basically find its value. So let's name it as I again. So it is integration from pi by 6 to pi by 3 sin x raised 1 by 3 divided by sin x raised 1 by 3 plus cos x raised 1 by 3 dx. Now if you see that, like in this, if I use this form result, basically property of definite integral, that is integration from a to b fx dx, then that is equals to integration from a to b f of a plus b minus x dx. Now if I just solve it, I'll get my I as equals to pi by 6 to pi by 3 sine of pi by 6 plus pi by 3 minus x raised power 1 by 3, likewise divided by sine of pi by 6 plus pi by 3 minus x raised 1 by 3 plus cos pi by 6 plus pi by 3 minus x raised 1 by 3 dx. So this term will be equals to integration from pi by 6 to pi by 3 sine pi by 3 plus pi by 6 is pi by 2 basically. So it will be sine pi by 2 minus x raised 1 by 3 divided by sine pi by 2 minus x raised 1 by 2 plus cos pi by 2 minus x raised 1 by 2 1 by 3 dx. Here also it's 1 by 3. Now if we further simplify it, we'll get integration from pi by 6 to pi by 3, and sin pi by 2 minus x is cos x, so it will be cos x raised 1 by 3 divided by sin x raised 1 by 3 plus cos x raised 1 by 3 dx. Now let's just add in equation 1 and equation 2. So we'll get our 2i as integration from pi by 6 to pi by 3 sin x raised pi by 3 plus cos x raised 1 by 3 divided by sin x raised 1 by 3 plus cos x raised 1 by 3 dx. Now if you see that the term in numerator and denominator is same, so we can balance them out. So we'll left with integration from pi by 6 to pi by 3 and integrand is 1 into dx. So from here I got my I as 1 by 2 x, and limit varies from pi by 6 to pi by 3. So that basically gives us I as 1 by 2 into pi by 3 minus pi by 6. That is equals to 1 by 2 into pi by 3 minus pi by 6 is pi by 6. So from here I got my I as pi by 12. And that's what we are supposed to basically find in this question. So let's move on to the next question. So the next question says that we're supposed to evaluate the given definite integral. So let's do that. So it is given to us as 0 to 1 log e 1 plus x divided by 1 plus x square dx. So if in this question I assume let x to be my tan theta, then my d of x will be sec square theta d theta. Now let's just replace in these values in I. So my I reduces to, when my x is 0, theta is 0, and when my x is 1, theta is pi by 4. So limit changes from 0 to pi by 4. Integration log 1 plus tan theta divided by 1 plus tan square theta into dx, that is sec square theta d theta. And we know that 1 plus tan square theta is basically equals to sec square theta. So this basically gives us integration from 0 to pi by 4 log 1 plus tan theta divided by sec square theta into sec square theta d theta, and this sec square balances out this. So we'll get our I as integration 0 to pi by 4 log 1 plus tan theta d theta. Now herein let's use the result again, that is integration from a to b fx dx is equals to integration from a to b f a plus b minus x dx. So if we use it, we'll get it as integration from 0 to pi by 4 log 1 plus 10 pi by 4 plus 0, that is pi by 4 minus theta d theta. So this basically reduces to integration from 0 to pi by 4 log 1 plus, let's use it is tan of a minus b form, and we know that tan a minus b is basically equals to tan a minus tan b divided by 1 plus tan a tan b. So if we use it here, we'll get 10 pi by 4 is basically 1 minus tan theta divided by 1 plus tan theta d theta. Now let's just simplify it. So we'll get 0 to pi by 4 log 1 plus tan theta plus 1 minus tan theta divided by 1 plus tan theta d theta. So this tan theta balances out this. So we left with integration 0 to pi by 4 log 2 divided by 1 plus tan theta d theta, and it is equals to I. Now if we just name this equation I, let this as 1 and this as 2, and just add in these two equations. So we'll get it as 2i is equals to 0 to pi by 4 log 1 plus tan theta plus log 2 divided by 1 plus tan theta d theta. And we know that log holds a property that log of a into b is same as log a plus log b. So it reduces to integration 0 to pi by 4 log 1 plus tan theta into 2 divided by 1 plus tan theta into d theta. This 1 plus tan theta balances the one numerator, so it reduces to integration from 0 to pi by 4 log 2 d theta, and this log 2 is basically constant, so we can pull it out of the integration. So we'll be left with log 2 integration from 0 to pi by 4 d theta. So it is log 2 into pi by 4. But remember that on the left hand side we have 2i, and we're supposed to find out the value of I. That will be pi by 8 into log 2, and that's what we are basically supposed to find in this question. So let's move on to the next question. So in the next question they have basically given us a function fx in term, and that is basically an integration function, and we're supposed to evaluate f of e plus f of 1 by e. So let's see what our function fx is. Equals to integration from 1 to x ln t divided by 1 by t dt. So we are supposed to find out value of f of e plus f of 1 by e. Now let's see what will be our f of e. It will be equals to integration from 1 to e ln t divided by 1 plus t dt, and f of 1 by e will be equals to integration from 1 to 1 by e ln t divided by 1 plus t dt. Now if we see our f of 1 by e, that is equals to integration from 1 to 1 by e ln t divided by 1 plus t dt. Now let us assume that my t is equals to 1 by y. So if t is 1 by y, then for t equals to 1, my limit of y is also equals to 1, and for t equals to 1 by e, my y is equals to e. So my f of 1 by e reduces to integration 1 to e ln 1 by y divided by 1 plus 1 by y, and if you take derivative of t, it will be minus 1 by y square into dy. So dt is minus 1 by y square into dy. So it reduces to integration 1 to e minus ln y, because ln of a by b is ln a minus ln b, and ln block 1 is basically equals to 0. So it is ln minus ln y divided by y plus 1 by y into minus 1 by y square into dy, and it will be equals to 1 to e and it will reduce to ln y into y by y plus 1 into 1 by y square into dy. This y balances out one power in denominator, so we'll get it as integration from 1 to e ln y divided by y into 1 plus y dy. This is equals to f of 1 by e, but we're supposed to find out value of f of e plus f of 1 by e. So that will be integration from 1 to e ln t by 1 plus t dt, and we know that like y is a variable, and in definite integral changing variable doesn't affect the integration, so it is same thing as 1 to e ln t divided by 1 plus t into t dt. So f of 1 by e will be 1 to e ln t divided by 1 plus t into t dt. Now if I just simplify it, what I can do is I can write it as ln t by 1 plus t plus ln t by 1 plus t into t dt. On further simplifying it, we'll get 1 by e into, I can plug pull out ln t by 1 plus t from both the terms. So I'll be left with 1 plus 1 by t dt, and this thing will be equals to 1 to e ln t divided by 1 plus t into 1 plus t by t dt, and this 1 plus t in numerator balances the 1 in numerator. So our final integral results into integration from 1 to t, 1 to e, basically ln t by t dt. Now we are supposed to solve this integral, and if I just let in, let my ln t is equals to y, so from here I'll get 1 by t dt is equals to dy. So I can write this above term as integration from 1 to e ln t into dt by t, right? So from here my f of e plus f of 1 by e will be basically equals to integration from, when my t is 1, so y will be 0, and when my t is e, y will be 1. So integration from 0 to 1 y dy, so that is y square by 2, and limit varying from 0 to 1, that basically gives us 1 by 2 minus 0, and it is equals to, final value is equals to 1 by 2. So let's move on to the next question. So in the next question they have given us an integral, and we are supposed to basically evaluate it. So let's name it as I, and it is varying from 0 to 1, and we are supposed to integrate 2x sine 1 by x minus cos 1 by x dx. So we can write it as integration 0 to 1 2x sine 1 by x dx minus integration from 0 to 1 cos 1 by x dx. Now if I just apply integration by part on this term using integration by parts on term 1, so I'll get my I as equals to, let's name it as a first function and this as second function. So it will be, first function is same, that is sine 1 by x, into integration of second function, that is integration of 2x will be x square, and limit from 0 to 1 minus differentiation of first function, that is differentiation of sine 1 by x will be cos 1 by x, and by chain rule we are supposed to differentiate this 1 by x as well, that will give us minus 1 by x square, into integration of second term, that is x square and dx, and limit is varying from 0 to 1, and 0 to 1 cos 1 by x dx. So if I just simplify it, I'll get sine of 1 into 1 minus 0. This limit is 0 because sine value varies in between 0 to minus 1 to 1, so this will be some finite value into 0, so this whole term will be 0 minus this x square balances out the 1 in numerator, and this minus and hit minus, it makes it plus integration 0 to 1 cos 1 by x dx minus integration 0 to 1 cos 1 by x dx. So this term balances out this, so our integration is basically equals to sine 1. So now let's move on to the next question. So in the next question they have basically given us a definite integral and we're supposed to evaluate its value. So let's name the integral as 1. So it is from 0 to pi by 2 x sine x cos x divided by sine x raised 4 plus cos x raised 4 dx. Now if I just use the result, that is integration from a to b fx dx is equals to integration from a to b f of a plus b minus x dx, 0 to pi by 2 and pi by 2 minus x into sine pi by 2 minus x into cos pi by 2 minus x divided by sin pi by 2 minus x raised 4 plus cos pi by 2 minus x raised 4 into dx. And we know that sin 90 minus theta and cos is equals to cos theta, and cos 90 minus theta is sin theta. So it will reduce to 0 to pi by 2 minus x cos x into sin x divided by cos x raised 4 plus sin x raised 4 dx. So it further reduces to integration from 0 to pi by 2 sin x cos x minus x sin x cos x divided by sin x raised 4 plus cos x raised 4 dx. Now if I just add in the original equation, that is number 1 and this 2, like adding 1 with 2, so I'll basically get 2 of I is equals to 0 to pi by 2. Now if you see that there is x sin x cos x, and denominator in both the terms is same, so I'm just combining it. It will be pi by 2 sin x cos x minus x sin x cos x divided by sin x raised 4 plus cos x raised 4 dx. This x sin x balances this one, so it is equals to pi by 2. We can take pi by 2 out of the integral sign because it is a constant. Integration from 0 to pi by 2 sin x cos x divided by sin x raised 4 plus cos x raised 4 dx. So I got my I equals to pi by 4 0 to pi by 2 sin x cos x by sin x raised 4 plus cos x raised 4 dx. Now to solve it from here, let's take let's divide both numerator and denominator by cos x raised 4. So my I will basically reduce to pi by 4 integration from 0 to pi by 2 sin x cos x by cos x raised 4 divided by sin x raised 4 plus cos x raised 4 divided by cos x raised 4 dx. So if I just simplify it, it will be equals to pi by 4 integration from 0 to pi by 2, and in numerator will be left with 10x into sec square x, and in denominator it will be 10x raised 4 plus 1 dx. Now if I let my 10 square x equals to u, so it will basically reduce my limits from at x equals to 0 u will be 0, and at x equals to pi by 2 my u will be basically infinity. So I reduces to pi by 4 integration from 0 to infinity, and if I just differentiate it, it will be 2 10x sec square x dx is equals to du. So from here I can find out value of 10x sec square x dx, that will be equals to du by 2. So let's just plug in these values. So it will be du by u divided by u square plus 1, du by 2 it is. I can just pull out this 2 out of the integration sign, so it will be basically equals to pi by 8 integration from 0 to infinity du by 1 plus u square, that is equals to pi by 8 into tan inverse u, and limit varying from 0 to infinity. So that is equals to pi by 8 into tan inverse infinity minus tan inverse u. So that is equals to pi by 8 into tan inverse infinity is basically pi by 2 minus tan inverse 0 is 0. So it is equals to pi square by 16. So my I is basically equals to pi square by 16. This is the value of the given definite integral. So let's move on to the next question. So in this question we are supposed to integrate ln x and the limit is varying from 0 to 1. So integration from 0 to 1 ln x dx is equals to, I can write it as integration from 0 to 1 ln x into 1 dx. Now let's just take ln x as first function and 1 as second function and use integration by parts. Using integration by parts, we'll get it as equals to first function same, integration of second function that is x, minus a differentiation of first function that will be 1 by x into integration of first that is x and whole integration leading from 0 to 1. So it will be equals to ln 1 into 1 minus ln 0 into 0 minus x and limit varying from 0 to 1. ln 1 is 0 and limit of ln x at 0 we are supposed to find because it won't be defined if we just directly put it. So limit x approaches 0, ln x into x will be equals to limit x approaches 0 ln x by 1 by x. It will be limit x approaches 0 ln x using L'Hopital rule here will give us 1 by x divided by minus 1 by x square, and it will be equals to limit x approaches 0 minus of x, that gives us basically 0. So this limit reduces to 0 minus 1 minus 0, so the integration value becomes basically minus of 1. So let's move on to the next question. So in the next question we are supposed to evaluate this limit. So that is, let's name it as I for time being. So it will be equals to 0 to 1 x ln x cube dx. So I can write it as integration from 0 to 1 x ln x cube into 1 dx, and let's name this as first function and this as second function. So if I use here integration by parts, so I'll get my first function same, that is x ln x cube into integration of second function that is x 0 to 1 minus integration from 0 to 1 differentiation of first function that will be 3x ln x square into x into 1 by x plus ln x and into integration of second function that would be x dx. So if I just simplify it, it will be 1 ln 1 that is 0 minus 0, this limit will be basically 0 minus, I can just pull out 3 integration 0 to 1 x ln x square into 1 plus ln x into x dx. So it will be equals to minus 3 integration from 0 to 1 x into x ln x square plus x ln x cube into dx. Now if I can write it as minus of 3 integration from 0 to 1 x into ln x square minus 3 integration from 0 to 1 x ln x cube dx. Now if you see that this is the value of integration that we are supposed to solve and we assumed it to be I. So it reduces to I is equals to minus 3 integration from 0 to 1 x ln x square dx minus of 3i. So that basically gives us 4 of I is equals to minus 3 integration 0 to 1 x into x ln x square dx. Now I can write it as minus 3 integration 0 to 1 x cube into ln x square dx. Now let us assume this ln x square as first function and this x cube as second function, and let's just apply integration by parts again here. So what we'll get it as minus 3 into first function same, that is ln x square, into integration of second function, that will be x raised by 4 by 4, and here limit from 0 to 1, minus whole integration 0 to 1, differentiation of first function, that will be 2 ln x into 1 by x, into integration of second function, that will be x raised 4 by 4 dx. That basically simplifies to, if you plug in limit here, ln 1 will be 0 and this basically reduces to 0, minus integration 0 to 1, I can just pull out this 2 and this 4, that will be minus of 1 by 2 ln x into x cube dx. So it reduces to 1 by 2, here we have 3 also, so it will be 3 by 2 integration 0 to 1 ln x into x cube dx. Now if I just assume this as first function and this is second function, and again use integration by parts here, so we'll get 3 by 2 into first function same into integration of second function, minus whole integration from 0 to 1, differentiation of first function, that would be 1 by x, into integration of second function into dx. So this will basically gives us 3 by 2 into, this limit will basically be 0, minus 1 by 4 integration from 0 to 1 x cube dx. So this will be equals to 3 by 2 into minus 1 by 4 into x raised 4 by 4 and limit varying from 0 to 1. So it will be equals to 3 minus 3 by 8 into 1 by 4 minus 0, that is minus 3 by 8 4s are 32. But if you see that on the left hand side we have 4 of I, and we are supposed to basically calculate value of 3 of I, basically value of I. So I will be minus 3 by 4 into 32, and that is equals to minus 3 by 4 2s are 8 and 4 3s are 12, that is minus 3 by 128 is basically final value of this integration. So that's all for this part of the video, that only these many questions were asked on definite integral, and like in the next video we'll basically see questions related to indefinite integral. So please like, share and subscribe the channel, and thank you for watching.